Hello, welcome to this course titled Basic Mathematics. My name is Nnamdi Augustus Isichei and I will be your lecturer for this course. In this first lecture, we shall focus on the introduction to real numbers. We will explore the basic concepts of real numbers and how they are different from other types of numbers. Let me start by asking you a question. What comes to your mind when you hear the word number? Perhaps you're thinking of counting numbers like 1, 2, 3, or maybe negative numbers like -1, -2, -3. Or what about numbers like pi or the square root of 2? These are also numbers, but they don't fit into the category of counting numbers or negative numbers. This is where real numbers come into play. Therefore, real numbers are a collection of all numbers that can be expressed as a decimal, including those with infinite number of decimal places. In other words, real numbers encompass several types of numbers, including natural numbers, which are also counting numbers, integers, which are positive and negative whole numbers, including 0, rational numbers, which are numbers that can be expressed as fractions or decimals, and irrational numbers, which are numbers that cannot be expressed as fractions. There exists specific symbols that are utilized to represent these number systems. For real numbers, it is denoted with the double stroke R. Rational numbers are denoted with the double stroke Q. The double stroke I is used to denoting the set of irrational numbers, while integers and natural numbers are denoted with the double stroke Z and N respectively. Now, let's talk about the important concepts related to real numbers, the number line. Imagine a straight line where all real numbers are represented by a point on the line. You can think of this line as a ruler, where each point on the line corresponds to a specific real number. The number line can help us visualize and understand the relationships between different real numbers. For instance, let's say we have two real numbers, 2 and 5. We can represent them on the number line as 2 points that are separated by a distance of 3 units. Similarly, if we have two real numbers, -2 and -5, we can represent them on the number line as 2 points that are separated by a distance of 3 units, but in the opposite direction. I trust these explanations have helped you grasp the concept of how real numbers are depicted on the number lines. Now, let's briefly discuss some basic properties of real numbers. Real numbers have a lot of properties, but we will discuss the most important ones. The first property is the closure property. The closure property states that when you add or multiply two real numbers, the result is always another real number. In other words, real numbers are closed under addition and multiplication. To demonstrate this concept, let's take two real numbers, for example, 4 and -7. If we add these numbers, the result is -3, which is also a real number. Likewise, if we multiply these numbers, we get -28, which is also a real number. The second property we will discuss is the commutative property of real numbers. This property states that the order of real numbers does not affect the result when you add or multiply them. In other words, when you add or multiply two or more real numbers, you can change the order of numbers and still get the same result. For example, if you have the real numbers 2, 3, and 4, the commutative property tells us that 2 plus 3 plus 4 is equal to 9. Similarly, 3 plus 4 plus 2 is equal to 9. And 4 plus 2 plus 3 is also equal to 9. Likewise for multiplication, 2 times 3 times 4 is equal to 24. Similarly, 3 times 4 times 2 is equal to 24. And 4 times 2 times 3 is also equal to 24. So, commutative property of real numbers tells us that the order in which we add or multiply the numbers does not change the result. Let us discuss the third property, which is the associative property. The associative property states that when you add or multiply 3 or more real numbers, it doesn't matter how you group them. In other words, we can change the grouping of the numbers without changing the final result. For example, if we have 3 real numbers, 2, 3, and 4, the associative property tells us that brackets opened, 2 plus 3 brackets closed plus 4 is equal to 9. 2 plus brackets opened, 3 plus 4 brackets closed is equal to 9. Likewise, for multiplication, brackets opened, 2 times 3 brackets closed times 4 is equal to 24. 2 times brackets opened, 3 times 4 brackets closed is equal to 24. So, the associative property of real numbers tells us that the way we group 3 or more numbers when we add or multiply them does not affect the final result. The third and final property we will discuss is the distributive property. The distributive property states that when you multiply a real number by a sum or difference of 2 other real numbers, you can distribute the multiplication over each term. In other words, you can break up a multiplication over an addition or subtraction. For example, if we have real numbers 2, 3, or 4, the distributive property tells us that 2 times brackets opened, 3 plus 4 brackets closed is equal to 2 times 3 plus 2 times 4, which is equal to 6 plus 8, and that is equal to 14. 2 times brackets opened, 3 minus 4 brackets closed is equal to 2 times 3 minus 2 times 4, which is equal to 6 minus 8, and that is equal to -2. In addition to the basic properties of real numbers, there are some other important concepts to keep in mind. One of these is the absolute value denoted by 2 vertical bars. The absolute value of a real number is its distance from 0 on the number line, regardless of the direction. For example, the absolute value of -3 is 3, and the absolute value of 3 is also 3. Another important concept is inequality. When you compare 2 real numbers, we can use the symbols less than, greater than, less than or equal to, or greater than or equal to represent their relationship. For instance, we can say that 2 is less than 5, or -5 is less than or equal to 2. These symbols help us understand the relative positions of different real numbers on the number line. To wrap up, real numbers are a vast and important topic in mathematics. They are essential for understanding many mathematical concepts like algebra and calculus. Understanding the basics of real numbers, including their properties and relationships, is fundamental for success in mathematics. So, let's continue exploring this topic in our next class. Goodbye.